Mahavidyalaya Ausa, District Latur. It's organized World Record Series 2. Today there is 233rd session of the World Record Series. And the keynote speaker for today's session is Honorable Dr.Sheela A. Sangam Madam. So with this, first of all, I welcome to you, Madam, for the session. I welcome the Chief Organizer of the series, Honorable Principal M. Ambedkar, sir. I welcome the faculty members from my college, Dr. Sanjay Ghogre, sir, Honorable Praveen Udge, sir, and others, and heartily welcomes all those dear participants. The topic for today's presentation is nanomaterial in degradation study. Now this topic is going to present and Honorable Sheela Madam. It's my pleasure to introduce that Madam is serving as an assistant professor at KLS Gogte Institute of Technology, Udyambag, Belagavi, Karnataka. So with this brief introduction, now I request you, Madam, please start your presentation on the topic nanomaterials in degradation study. You are most welcome.
Hello, good evening, everyone.
Good evening, Madam. Most welcome.
Yes.
Yes.
I hope my screen is visible to you all, sir. Is it visible? Yeah.
Just a minute, sir. There is a problem. Just. Yeah, yes.
Is it visible, sir, now? Hello. Yeah.
Yes, yes, madam.
So, good evening, everyone. So, today I am focusing on the nanomaterials in degradation study. Myself, Dr.Sheela A.Sangam from KLS Gogte Institute of Technology, Belagavi, Karnataka. So, as we know that the nanomaterials are very much interesting and amazing properties. What is the main aspect of the amazing properties of these molecules and why we have to use these type of nanomaterials in our studies that we are focusing on now? So actually, the first of all, I want to tell you what are the nanomaterials. So as we know that the word nano is a great prefix meaning dwarf or something extremely very small. A nanometer scale that is usually known as nanometer, that is nm, is 1 billionth of the meter or 10 raised to minus 9 meter. When we go to the civilization, when we focus on the civilization, earlier it was a stone age and later it was a metal age and then a polymer age and now we are living in nano age. So this is what the importance of nanomaterials in our research. So, according to the IUPAC, nanomaterials are defined as the materials having sizes in the range of 1 to 100 nanometer. That is, 1 nanometer is equals to 10 raised to minus 9 meters. So, these are, if we want to imagine what is the actual size of these nanomaterials, we can say that is, I think you can see this slide. So when you go with a human hair, that is 100 micrometer. So when you cut this into 100 slices and you take one slice of that, that becomes 1 micrometer. And again, that 1 micrometer of hair is again sliced into 1,000 slices and the one slice is taken, that is considered as 1 nanometer. Then we can imagine what is the range of the nanometer size. So these are what some different examples of the nanomaterials. For example, when you go with gold nanoparticles and Buckminster fullerenes, as well as some ferrous platinum nanospheres, these are the some examples. Titanium nanoflower and silver nanocubes and tin oxide nanoflowers. These are the some different types of the structures of nanomaterials which we can synthesize in our laboratory. So then why we are focusing this much? Why the interest has been taken on these nanomaterials? Especially when we go with the nanomaterials, all these are size dependent. Whatever the properties we study in this nanomaterial is size dependent. So actually what happens here, we are observing the amazing change when it goes to the properties of nanomaterials. So actually the simple example for this is the gold, whatever we are, just a minute, there is some problem. Okay. Can you see my slides, sir? Is it visible to you? Yes, sir. Yes, sir. That is a problem. So just share it once again. Okay. Okay. So when we go with the gold,
Visible.
is it visible, sir? Now?
Yes, madam.
Yes. Gold. So when we go with a bulk gold, the actual optical property of the gold, that is, it looks like a yellow in color. But when we come into a nanoparticle of these, then actually these appears in the red coloration. See the difference. Actual, the optical properties are completely different from the bulk material. In the same way, when we go with the zinc oxide nanoparticles, so actually zinc oxide nanoparticles are of nowhere absorption interest. When we go with the nanoparticles of these zinc oxide nanoparticles are used in the UV wave absorbing materials. So usually in most of the sunscreens, we are using these type of nanomaterials. And when we go with the chemical properties, actually already I have gone with the gold. So when the gold, bulk gold is taken, these bulk gold, this is especially this bulk gold, it is non-reactive. We know this, everyone know very well. But when it is converted into a nanoparticle, this becomes a very highly reactive material. So this can be utilized in the catalysis reactions. So as a catalyst, we can use it, and we can in the purification, most of the purification of gases, we are using these type of gold nanoparticles. And even when we go with the mechanical properties, so even the mechanical properties of the material also increased or the strengthened by using these nanoparticles. Then how actually these are strengthened? Actually, what happens here, the defect, whatever the surface defect is there, that is reduced when the particle from the bulk is converted into nano. So because of that, what happens, if the defects are reduced, then the strength of the material is extremely increased. So in this way, we are increasing the mechanical properties. So I have given some examples also here. And when the same thing here I represented here, that is, the copper nanoparticles smaller than 50 nanometer are considered super hard materials that do not exhibit the same malleability and the ductility as the bulk copper. So when we go with the bulk copper, it is very ductile in nature. We can make a sheet of this and it is very tensile. But when it is converted into a nanomaterial, then it becomes extremely hard. We cannot convert into thin wire or else sheet. That is what the main mechanical property, how we can strengthen by using these nanotechnology. So even the magnetic properties are also improved. So when we take an example of a bulk gold or a platinum, these are non-magnetic in nature, but when these are converted into a nanomaterial, these are these becomes highly magnetic. Then why you have to go with all these properties? You may have some question, isn't it? So what happens here when we convert any material from bulk to nano? The properties are extremely different. Amazingly and drastically, the properties are changed. So because of this reason, we are focusing most on these type of nanotechnology and nanomaterials. Then what is the use of these type of nanomaterials in this degradation study? The most one thing I want to say that whenever any bulk material is converted into nanoparticle, then the active sites of the material will increase by increasing the surface area. So as we know that the catalytic property of the molecule or the material will drastically increase. So because of this, we can say the nanomaterials acts as a very good catalyst. Then by studying all these properties, we are very curious. I think each and everyone will be very curious how actually these nanomaterials are synthesized in our lab. So actually there will be of two types of the processes. One is the bottom up approach, another one is top down approach. These are the two approaches. By using this, we can synthesize the nanomaterials in our laboratory. So when we go with this side, it will be a very clear. So top down approach, top down, it means what? We are cutting a big molecule into a nano. That is called as what? The top-down approach. There is a lot of net problem.
I can't believe it.
Net problem. So because of that, presentation is hindering. I'm extremely sorry for this disturbance. Yeah, 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 yes, sure. So top-down approach and the bottom-down approach. These are the two different types of synthesis of nanoparticles in our lab. So what happens here? The top-down approach. The example is so usually while making the ball milling and lithography, etc., we can synthesize the nanomaterial by using the top-down approach. And bottom-up approach is usually done by the process that is sol gel method and chemical vapor deposition method, that is also called as CVD, inert gas condensation method. These are the different methods of the synthesis by which we are going to synthesize these type of nanomaterials. Then what is the main application? So now it goes very interesting that the nanomaterials plays very interesting role and the very interesting application in each and every field, even in a medical field as well as in synthetic field and in catalytic field. Each and every field is now focused on this nanomaterials. Even we are going with some electronic materials also, by LCD, QLED, quantum dot cells. Everywhere we are using these type of nanomaterials, and even the very important that is water treatment. Even we are going with the nanomaterials in the water treatment. So here the main application comes water and the wastewater treatment by photocatalysis. So here, when we go with the water and wastewater treatment by photocatalysis, we should know what is the photocatalysis. Photocatalysis is nothing but what? The degradation of any material into a smaller one. That is called as photocatalysis. By using light, sunlight, we are converting the bigger molecules into a smaller one. That is called as photocatalytic process. Why you have to go with these type of photocatalysis processes? The main thing, the photocatalysis process, it doesn't involve much chemicals, and because of that, what happens here? This photocatalytic reaction becomes nature friendly. Nature friendly reactions. So these nature friendly reactions nowadays have taken very much focus and the very interesting part of our research. So here, the photocatalytic degradation I have done in my lab by using the polyphenol drug and the ferromagnetic nanoparticles. So these ferromagnetic nanoparticles are synthesized by using the sol gel method, that is bottom up approach. By using that, we are going with the photo degradation. Means by means of UV light, we are degrading. Degradation means what? The harmful molecules are converted into less harmful molecules, and the bigger molecules are converted into a small grade molecules. So mainly what happens here during most of the industry effluents as well as the medical effluents, whatever we are getting day-to-day basis, these are released into the water resources, which will contaminate our natural resources. So just to purify these type of effluents, we are going with some degradation processes. So conventional degradation processes are very much useful, but by going with these type of nanomaterials and photocatalytic nanomaterials, we can increase the efficiency of the degradation processes. The example is the photocatalytic degradation of polyperdon drug used in novel ferromagnetic nanoparticles. Polyperdon is a drug which is used antipsychotic as an antipsychotic drug in our medical. And this polyperdon, that is antipsychotic drug, is continuously released by excreta of any of the patient, and that will be released into a natural resource. So because of that, what happens, there will be a lot of contamination, and how to reduce these contamination we can study by using these photocatalytic degradation of polyperdon drug using the novel ferromagnetic nanoparticles. This is what the molecular formula of our drug, and the molecular mass is 426.484 gram. The experimental processes are, first you have to prepare a definite or a specific concentration of the drug, and that is mixed with nanoparticles, and the whatever the UV spectrophotometer and the instrumental whatever we have used, that I have given already in the pictures that you can see here. These are the instruments used during this study. This is the Carry 50 Bio UV visible spectrophotometer, and this is one more, the UV cabinet. You can use direct sunlight also, but if you want to proceed with the higher rate of the reaction, you can go with this UV cabinet also. And this is what the separation, that is centrifuging machine, which we are using for the separation of nanomaterials from the reactant. So what happens here, at first we have to mix these nanoparticles with our reactant, that is polyperdon concentration solution, and that will be kept in the UV cabinet. After keeping it in a cabinet, at first we have to adjust the UV cabinet, that a spectrophotometer, to 278 nanometer, and the absorption of the maximum absorption of the polyperdon is 278 nanometer. So after this, after keeping it for different intervals of the time, for example, 10 minutes, 15 minutes, 20 minutes, 45 minutes, 1 hour, 2 hours, we are going to check how actually the degradation of the polymer takes place. So when we kept without nanoparticle, there won't be any degradation. Why? Because this polyperdon drug, in presence of UV light, the percentage degradation is very less, just it is of 2 to 3% of degradation. But when we mix it with the nanoparticle which we have synthesized, then what happens, there will be, we have observed some degradation. So this is what the absorption with respect to the time using the nanoparticles at 298 Kelvin. So this is the graph you can see here. So here, as the time increases, there will be a decrease in the absorption. The decrease in the absorption of polyperdon. It means what? At the first, whatever we are observing at 0, the polyperdon concentration is higher side. So that can be observed in the observation. So observation, the absorption is more here. It means what? The polyperdon concentration is higher side. But when we go this, when we go on adding, go on increasing the concentration, when we go on increasing the concentration of this polyperdon, we can see how actually the degradation is taking place. So degradation is continuously increasing when we increase the nanoparticle concentration. In the same way, if you observe the another slide, so this is what the another slide. Here the percentage of the degradation can be studied. So here just by using the concentration. If we are using the less concentration of the nanoparticle, then only 10%. And when we increase it to 1%, that is 1 milligram, then it is of 40% degradation. And when we increase it to 60%, then it is of almost 50% increase in the degradation. And when we increase again the concentration of nanoparticle, then we are getting 80% of degradation. That indicates as the nanoparticles increases, the concentration of the nanoparticles in the polyphenol drug increases, it increases the degradation. So in this way, we can purify the water, the natural resource. Before letting into these effluent sample, we can purify our effluent samples. Then after this purification, we can introduce these type of water sample into water resources that would be beneficial and which will prevent our environment. So when we go with the conclusion part, the main thing here is the degradative study of drug polypredon by UV visible light in the presence of acid medium forms lower masses of degradation products. So here, whatever the degradation products we are getting, these are of lower mass as well as these are less harmful when compared to the actual molecule of polypredon. And the next one, these formed products are less harmful and these are uh, when these are introduced into the domestic life, these won't harm any of the domestic animal or else domestic uh, material. So now the reactants and whatever the reagents utilized or used in the reactions are environmental friendly, and hence the reagents can be used in the purification of water in the wastewater treatment also. Insoluble manganese dioxide formed during the reaction provides an important role in the elimination of phenols, phenol derivatives, and other organic waste present in the water. So, by means of this, we can conclude that using these nanomaterials can be very useful in the water treatment, and these are less harmful and environmental friendly, as well as we can get the quick results by using these type of nanomaterials in our degradation study. Thank you very much. If any queries, you please proceed with.
Thank you very much, madam, for the wonderful presentation.
Thank you, sir.
Now I request dear participants, if you have any query, please ask to Honorable Madam. Dear participants.
Yeah, sir, sure.
Hello, madam.
Yeah, sir. Just a minute. I'll
Yes,
load my key.
yes sir, please. Welcome, Dr. Oza,
Yes.
sir. Please welcome.
Madam,
Yes.
nanotechnology where are useful for where what sector can use this nanotechnology, madam?
Sir, actually, when we go with the nanotechnology, in each and every field nowadays we are going with the nanotechnology. Even we can go in a medical field. Even in medical field like cancer and all, most of these type of cancer and most dangerous diseases can be treated by using these nanomaterials. And for example, even when we go with the hardest material on the earth nowadays is graphene. So actually the graphite is a very smooth and soft metal. We know. But just by removing one layer of this graphite, which is formed, that is a graphene, now it has become a very hard material, hardest material in the world. So for that only that purpose, one of our scientists has got a Nobel Prize for this graphene synthesis. I think you know about this. And
Thank you.
even one more thing I want to clarify here. So, for example, nowadays where already it is under research, some of the dirt-free cloths are synthesizing by using this nanotechnology. So, these are what the recent advancement in the nanotechnologies. Any?
Can diseases rectify the nanotechnology, madam?
We can't say rectify, sir. So actually, in the treatment of most of the diseases, we are using these nanomaterials, sir.
Yes, ma'am. Thank you.
Yes.
Thank you.
Yes.
Thank you very much.
Yeah. Thank you very much.
गुड इवनिंग मैडम.
Yes, sir. Good evening, sir.
इन कॉपर आपने कॉपर एलिमेंट लिया था, है ना?
हाँ सर. हाँ सर.
तो इंक्रीज द टेम्परेचर लीड टू ग्रेट इंप्रूवमेंट इन मैग्नेटिक प्रॉपर्टीज.
Yes, sir. Sure. Yes.
तो भाई कैसे?
No, sir. Actually, what I want to say is, so when you go with the copper bulk material, that we can we know that we can convert into a wire or else a thin sheet like that. We can do that. But when we convert these bulk copper into a nanomaterial, then what happens here, sir? It goes very hard. So we cannot immediately convert without applying much pressure. We cannot convert into wire or else a thin sheet. That is the main. So in this way, by converting bulk copper into a nano, we can increase the hardness in the metals. That is the thing.
नहीं, हार्डनेस मैग्नेटिक प्रॉपर्टी की बात कर रहे हैं मैडम.
No, sir. Malleability. It is not melting. It is malleability.
No, magnetic properties.
Magnetic properties.
Yes.
Okay. Sir. Even magnetic property, what happens here? When we go with the magnetic property, so what happens here? Most of the bulk to nanomaterial conversion will lead into a magnetic property. That only I can say, sir.
No. Increase the temperature, the magnetic property is less. है ना?
हाँ, sir.
So कॉपर में ऐसा क्यों?
Sir, in copper, I think I have not explained about the magnetic properties, sir, here. So only the malleability I have explained here. Malleability and ductility.
Okay.
हाँ.
So magnetic property नहीं.
हाँ.
Okay.
Good evening, Dr. Bedkar, sir. Good evening, madam. Wonderful presentation. This is a really advanced technology. What we are talking now, nanotechnology and nanoparticles. Usually in medicine, we are using a word nanoparticles. One very important thing what we can learn, if we are breaking the smaller and smaller molecule, the bigger energy is released or bigger energy is required to break it. That is one thing. Sure. That is one thing. I belong to homeopathic field, and very recently IIT Mumbai, Dr. Bilare, he has done a work on homeopathy, and many of the people talk about homeopathic medicines are diluent or diluted, but it is not diluted. It is broken down into nanoparticle. That is what he has proved by his very recent. This is a very recent study of IIT Mumbai Chemical Engineering Department. They have done this. And definitely it has existence, because many of the times we consider that after the crossing Avogadro's number, the physics doesn't believe in the material as such. But I think, yes, definitely nanoparticle, we have not reached to that depth. And it has a wonderful field, I think. Nanoparticle, because many of the medicines cannot go through mucous membrane or capillaries, and so these nanoparticles can be, they can be worked with, and we can work with medicine. Definitely nowadays people are talking about the small robotics, what we are talking about, nano robotics or robotics in medicinal field nowadays coming forward. That is a very advanced study is coming forward, and very soon, maybe in through 2 or 3 decades, the things will become so easy. The diseases which appear to be are more dangerous and more lethal to the humankind, they will become very easy to treat with such a kind of great initiative.
Yeah.
Thank you, madam. Very wonderful presentation you had given. Thank you.
Yes, sir. Thank you, sir. In regardance with the Prashant sir, whatever he has told, actually in the medicine we are using again one more silver, that is bhasma. We are using bhasma. So actually, in recent years also we are using that, but it is not discovered yet. But now, if we go with some research papers, we can recognize that these gold bhasma and the silver bhasma are utilized in the treatment of some skin diseases. So these are nothing but the nanoparticles which are used in the treatment.
I am Dr. C.B. Oja, Government College, Radhagad, MP. Yes. Okay, sir.
Yes, yes. If still any queries, you can.
Yes. Dear participants, once again, I request you all, please, if you have any query, please come ahead. Dear participants. So thank you, Dr. Oza sir, Sharan Basappa sir, Dr. Swan Shukla sir, for your queries. And thanks to Sheela madam, she have answered very nicely. Now I request the chief organizer of the series, Honorable Principal M. Betkar sir. Sir, please come ahead and give some words for today's session. Please welcome.
Thank you very much, sir. Okay.
Thank you, sir. Now I move towards the vote of thanks. Shri Kumarswami Mahavidyalaya Ausa, District Latur, in Maharashtra State. As we know, organized World Record Series 2. Today there was 233rd session of the long series. And the topic for today's presentation was nanomaterials in a degradation study. Now this topic have presented by Honorable Dr.Sheela A.Sangam Madam. She is from Karnataka, Belagavi, and ma'am have explained the topic. She made her explanation in a simple language. Simply she explained all those things, that what is nanomaterial, different examples of nanomaterials, uses of nanomaterials and classification of nanomaterials, and photo catalyst and experimentals. All these points have covered in her lecture. Then mechanical properties, optical properties. Now these short points have explained in her explanations, in her expressions. So thank you so much, madam. You have explained so sincerely, clearly, and it was really informative session. We appreciated a lot. Then I thanks to the chief organizer of the series, Honorable Principal M. Ambedkar sir. Also thanks the colleagues from my college, Dr. Sanjay Kale sir, Anita Dhole madam, Honorable Praveen Utge sir. On screen I am seeing our colleagues, Dr. Sanjay Gogte sir, CB Ausa sir. And thanks to all dear participants, including Dr. Ausa sir, Sharan Basappa sir, Dr. Swaran Shukla sir, who joins regularly, ask nice queries, and also madam have answered it sincerely. So thank you so much to you all. Please fill the feedback link which is given in the chat box. With the kind permission of the chief organizer, I declare today's session is over. Once again, Sheela madam, you fill the gap of today's session.
Thank you.
So once again, I thank you so much, because you are emergency personality in today's session. So thank you very much.
Thank you very much for the opportunity given to you, sir. Dr. Bedkar sir has given me this opportunity. Thank you very much, sir. Sincerely, it's my pleasure actually. Thank you very much, sir. I look forward into these type of invitations. Yeah. 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 Thank you, sir. Yes. Thank you. Thank you, sir. Good night.
Yes, sir.